Let us look at how we can solve the given expression without using a calculator. Before diving into the solution of this problem, let us have a look at a general expression that we can use to find out the value of the actual question. So let us say that m is equal to 25. Then m plus 1 would be equal to 26, m plus 2 would be equal to 27, and m plus 3 would be equal to 28. Now what we will do is replace all these variables in these places. Then we get our general expression as m times m plus 1, m plus 2, and m plus 3 plus 1. What can we do to solve this expression now? At another glance, you might say that, oh, I have converted this into a general form. Why not multiply it again? But if we do that, you would get the same thing. And you would be repeating the same process as we discussed earlier. And that is going to take a very long time to solve. So what we are going to do is try to find some hidden pattern in this expression. So what we'll do here is group two terms together, m and m plus 3 and m plus 1 and m plus 2. Let's now multiply these two terms. This gives us m square plus 3m, and this gives us m square plus 3m plus 2. Oh, now we see that there is something common in the two terms, m square plus 3m, m square plus 3m. So I'll consider that n be another variable which is equal to m square plus 3m. Now let's substitute n in this expression. This gives us n multiplied by n plus 2 plus 1. And now we can multiply it to get n square plus 2n plus 1. Oh, and now this is in the form of a square plus 2ab plus b square, which can also be written as a plus b whole square. Now the square and the root can be cancelled out, and now we will substitute the value of n in this expression. This gives us m square plus 3m plus 1. And now this difficult problem has been changed into a simpler one, where we just have to substitute the value of m to find our answer. Now let us substitute the value of m. In this case, m was equal to 25. So let us write 25 squared plus 3 times 25 plus 1. This gives us 625 plus 75 plus 1, which is equal to 701.